Lesson 3.2, choosing a sample. Our objective for this lesson is to be able to identify common sampling methods and explain whether a sample is likely to be representative of the population. Let's start by defining representative sample. A representative sample is a sample in which the relevant characteristics of the sample members are generally the same as those of the population. It's very important that we choose a representative sample because we're trying to determine a characteristic of the entire population by studying just a few members of that population. And if we haven't chosen a sample that's representative of the whole population, then it's not going to be very useful to us. Next, let's talk about some common sampling methods. The first is simple random sampling. So for simple random sampling, we choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. So this is just random. So we may flip a coin or roll dice. More often, what's going to happen is we're going to program a computer to just randomly select a few members of the population. So that's simple random sampling. Next is systematic sampling. So in systematic sampling, we use a simple system to choose the sample, such as selecting every 10th or every 50th member of the population. So here we may stand at the doorway to a supermarket and only interview every 10th person that comes through. So as long as we have that system and we stick to that system, that will hopefully give us a representative sample. Next is convenience sampling. So with convenience sampling, we choose a sample that is convenient to select, such as people that happen to be in the same classroom. We need to be careful with this because convenience sampling doesn't always give us a representative sample. For example, if we wanted to know the opinion of the entire school, it wouldn't necessarily be helpful for us to only interview the members of our classroom because our class has particular characteristics that might not be shared by the whole school. For example, everyone in this class is a senior, and so it's not going to be helpful. It's not going to be representative of the whole school. But a convenience sampling is just where you choose something that's going to be easiest for you to find. And finally, stratified sampling. So with stratified sampling, we first identify subgroups within a population and draw a simple random sample from within each subgroup. The total sample consists of all the samples from the individual subgroups. So we would do this if we're concerned about making sure that our sample gets some specific subgroups within our population. So for example, if we want to know, we want to do an opinion of the whole school, then maybe we want to make sure that we have equal numbers of freshmen, sophomores, juniors, and seniors. So maybe we select a random sample of freshmen, a random sample of sophomores, a random sample of juniors, and a random sample of seniors. And then our whole sample is going to be all of those people put together. For our examples, we're given a couple of scenarios, and we're asked to identify the sampling method used and also comment on whether or not the sampling method is likely to give us a representative sample. So for this first example, we're told that for a survey of students in a dormitory, you choose your sample by knocking on the door of every 10th room. So first of all, this is going to be an example of systematic sampling. Because we've got a system. We're knocking on every 10th door, and that's our system, and so it's going to be systematic sampling. The as for whether or not this is likely to give us a representative sample, I think it is, because our population is students in the dormitory. And by using this system, we're getting a sample of students throughout the dormitory. Now, we're not focusing on just one floor of the dormitory or one wing. We're getting students throughout the dormitory by knocking on every 10th door. Now, if our population were the entire school, then focusing on one dormitory wouldn't be a representative sample. But since the population is students in this dormitory, by knocking on every 10th door within the dormitory, we will get a representative sample. Our second example tells us that to survey opinions on a possible property tax increase, a research firm randomly draws the addresses of 150 homeowners from a public list of all homeowners. So this is going to be an example of simple random sampling. So here we're randomly selecting homeowners from this list. We could write all the names of the homeowners on pieces of paper, toss them in a hat, and pull them out randomly. Or more likely, we're going to ask a computer to randomly select names off of this list of all the homeowners. Now, is this likely to give us a representative sample? Well, if our population is just homeowners, then yeah, this would give us a representative sample of homeowners in the area. But we're not told that the population is just homeowners. We're told that we're trying to survey opinions on a possible property tax increase. So our population that we're interested in is probably all of the voters in that area. And if we want the opinions of all the voters in the area, we can't just choose our sample from homeowners. We need to make sure that we're choosing a representative sample of the entire population, which is going to include homeowners and also people who don't own a home. And so this isn't going to be a representative sample. And we could really get some skewed results by doing this, because people who don't own a home are likely to have a different opinion overall about a possible property tax increase than those who own a home.